Okay, welcome to this week 6, question 6. My name is Rohan and I'm going to dive right in. I'm going to advise you to be patient with this one. It may be a little longer than the typical one, but it's going to be worth it. The question is asking about a quarterly return for a group of 54 mutual funds. The mean is 4.1% and the standard deviation is 5.3. We are to assume that it's a normal model, and that's important for some of the calculations we're doing. And based on the model, and this is how it's written, the first expression is the mean and the next one is the standard deviation. We are asked to find the cutoff values. So at what percentage of return do we find the highest 30% of these funds, the lowest 40%, the middle 60%, and so on. Now, before we get into that, I want to show you real quick the bell curve and forgive the sketchy drawing. This is the typical bell curve, and a couple of things to note: that if you split it down the middle symmetrically, the shaded area here is going to represent 50% of your data points. So you're gonna have a balance once you do that, and this is gonna be your mean. And in terms of z-score, if you recall, your z-score there is gonna be equal to 1. So those are some background principles that you're gonna need to remember. Now let's dive in and look at the problem. I'm gonna show you first of all. I'm going to deviate a little bit and probably do part B just to show you a significant point. One of the things we want to note, in order to calculate, if for instance we wanted to calculate for the bell curve, we wanted to calculate the cutoff point for 30%, it means we're going to hypothetically have to find this point here, where this shaded region represents 30%. Now, the way the question is asked, we are always going to have to translate it to finding the cumulative value below a certain point. And let me see if I can bring that to life. If, for instance, we wanted to find the highest 30%, in order to find the highest 30%, we are going to be able to easily, the highest 30% is going to be preceded or followed, it's going to follow 70%. So if we're able to find the mark here where this shaded region represents 70%, it means that this shaded region will represent 30%. And that is going to be critical because mathematically it's going to be easier to calculate the cumulative values from 0 all the way up to a certain point, and then you can translate it if you're interested in other values. But I'm going to show you real quick how to get this point right here of interest, and once you learn that, then you will just have to think through the solution. So what is the cutoff point for a return of for the lowest 50%? Now clearly 50% is going to be equal to the mean, so mathematically the cumulative point for 50% is going to give you a z-score of 0, and this formula is what you use for z-score, and I'll come back to it. And you translate it to x using this formula here, you transpose in for x. So we know that x is going to be 0.041, and translating that into percentage, you get 4.1%. So let's see if we can find the cutoff return rate for 40%. Now, what we said earlier on, and if we come back to my bell curve, the point we are interested in For 40% is going to be just about here. We're interested in this cumulative value, where this represents 40% of your total. So it's going to be a little bit to the left of the peak of your normal distribution. Now, in order to calculate that, the cumulative point of interest is 40%. We're going to use the norm's inverse function, where if you input the percentage, it returns a z-score for that cutoff point. So what this formula is giving you is the z-score for this value. So our z-score of minus 0.253 would be corresponding to this point here. And essentially, z-score is just a standard way of measuring along a normal distribution. And at the mean, the z is 0, and at one standard deviation away, the z is going to be plus or minus 1, depending on which side. So what we're saying, at 10% less than the mean, the z-score is minus 0.253. Z-scores are negative in this region, and z-scores are positive in this region, and clearly along that line where the peak of the normal distribution is, the z-score is 0. Once you understand how to translate this point with a certain percentage cumulative into a z-score, and then translate a z-score back to x using this formula, you will be golden with this. So this is going to be the brunt of the question. So let's look at the question now to see if it flows a little better. So the first question is asking us to find the highest 30% of the scores. And just to reiterate that, the highest 30% is gonna be in this region where this is 30% cumulative, which means that what's left over here is going to be 70%. So the point of interest we are interested in is going to be the 70% cutoff point. So let's look at this. The 70% cutoff point means that 70% is less than the top 30. So that cutoff point we can calculate using the norm inverse, but this value C6 that is reading is 70%, so that we can get this point here, so that 30% is greater than that. So that's why we're using 70 in the equation, because the equation is giving us the cumulative value. That's the value from this point below. So if we want 30% to be above, it means 70% has to be below. Hence, we're using 70 in this formula here. Once we've found the z-score, we can find the x-score by pretty much transposing this formula here, where let's look at that real quick, and it's just a matter of transposing. If we have z is equal to x minus mu over sigma, then if we are interested in finding x, we do a little mathematics, and we end up with, so this formula here is what I have calculated here to give me the x scores. And since we're talking about returns, I have translated it here into percentage. And let me show you real quick how I did that. All I did was I copied this here and then made it a percentage. Right clicked and did a percentage. It's already embedded in that, but let's look at it here. If you paste this here, it's going to come up as a fraction. Right click on it, and then you are able to do the percentage, and it changes it, and you have to alter the number of decimal points you have. So that's how I got it to display that. So what, in looking at the problem now, it means that the highest 30% of the funds were cut off at 6.88% return. The next question is wanting to find the lowest 40%. Now with that, clearly the point of interest, the cumulative point that we're going to look at on the graph, if we may just look at this real quick, for the lowest 40% is going to be just 40% here. So this is going to be a straightforward point of interest is 40%. The point that you're going to put in this norms inverse function is 40%. It returns this z-score, and then I copied the formula from here down to here in order to calculate the x value, coming again from this equation here, transposing for x. Let me get that somewhere where you can see it. Right, just transposing this for x, and then we change it into a percentage. So what we're saying, to capture the lowest 40% of investors, they would have gotten interest up to 2.76. Now if we're looking to find the middle, the cutoff values for the middle 60%, now in order to get the middle 60%, remember we always want to translate this to cumulative values. So the middle 60% is going to mean that with 60% here, 40% is excluded, but that 40% is going to be divided equally between here and here. So this is going to be 20%, this is going to be 20%. But if we were to look at cumulative values, we will be interested in this cumulative value to find the first 20%, and then we're going to be interested in the cumulative values up to here, which is going to be 80%, since 20% is greater than that. So the two cumulative values we're going to seek to find will be 20 and 80, so that it captures 60% in between them. So looking at that real quick, it translates again to a similar problem. 40% is excluded, which means 20 is lower and 20 is higher. 20% lower means the cutoff point is 20%. I copied the formula here. That happens at minus 0.36% return. 20% on the high side, which means I'm interested in an 80% cumulative value, which is this point here that I'm interested in. Then that translates to 80%, put it in this formula here, translate it back to x, I get a return of 8.56%. So the two cutoff values to give me the middle 60% is minus 0.36 and 8.56. Now to get the highest 60%, it means that I have to use the cutoff value that shows me the lowest 40%, which is similar to question in part B, but the reasoning is just the reverse. So it's 40%, I find the z-score, and then I have x calculated there, and I convert it into a percentage. Alright, so this is going to take some time to go through and appreciate. One of the other things I used, let me put it here for highlight real quick. I did use this formula, norms inverse. It returns the inverse of the standard normal cumulative distribution, and that's the essence of what we did here. We also used this formula because we knew the value of z, we knew the value of sigma, we knew the value of mu, and we wanted to translate it back to an x value. We were able to get z from the standard formula here for the cutoff point, so we then had to translate it back to x. So that's pretty much what this question is about. Take your time, watch this video again. It's a little long, but it's necessary because it has a multiplicity of steps to get you to the correct responses. I'm also going to send out this Excel document so that you can look at it and make sure you are following what's there in that. One little trick with that, let me highlight it real quick. If you notice in this formula here, I have a dollar sign in front of the C and a dollar sign in front of the 3, and the same for the C and the 4. Because when I copy this formula down, I want it to constantly reference C3 and C4 without changing those, because I'm constantly referring to the mean and the standard deviation. Because this formula here is calling and referencing those values as constant regardless of what the z-score is. So if you notice d6 is different, that's going to be dependent on the z-score that I'm trying to find. Alright, so a couple of the tricks in this, but it should be all clear now. Take a look at it. Please feel free to reach out to one of us if you have any questions. Alright, this is Rohan. Thank you for watching.